NENOMATICA, where mathematics meets YouTube excellence. The addition and subtraction of powers. Welcome to this tutorial on exponent properties and rules. Before we study the sum or difference of powers, let's review the key laws of exponents with an example. The first rule we'll review is the product of powers. When we multiply powers with the same base, we add the exponents. The second rule is the power of a power. When we raise a power to another power, we multiply the exponents. The third rule is the quotient of powers. When we divide powers with the same base, we subtract the exponents. For any non-zero, a to the power n divided by a to the power m equals a to the power n minus m. The fourth rule deals with a power with a product. When we raise a product to a power, each factor is raised to that power. The fifth rule is about a power with a quotient. When we raise a quotient to a power, both numerator and denominator are raised to that power. For all b not equal to 0, over b to the power n equals a to the power n over b to the power n. The sixth rule deals with negative exponents in fractions. When we have a fraction with a negative exponent, we can invert the fraction and make the exponent positive. Over b raised to the negative n power equals b over a raised to the n power. The seventh rule is about products with negative exponents. When we raise a product to a negative power, it equals 1 over the product raised to the positive power. The eighth rule is about the reciprocal of a negative power. 1 over a to the negative n equals a to the n. The ninth rule deals with fractions that have negative exponents. When we have a fraction where both numerator and denominator have negative exponents, we can rewrite it as a reciprocal with positive exponents. Welcome to our mathematics lesson. Today we'll learn about adding and subtracting numbers with exponents. For the sum or difference of exponential numbers, we first need to recognize terms with the same base as similar expressions. Then, we'll proceed as with the algebraic sum of similar expressions. Let's look at an example from the image. We need to simplify the expression pa to the power of m plus rb to the power of n minus sa to the power of m plus hb to the power of n. First, we'll rearrange the expression to group terms with the same base. We can rewrite this as pa to the power of m minus sa to the power of m plus rb to the power of n plus hb to the power of n. Now we can factor out the common terms. From the first bracket, we can factor out a to the power of m. From the second bracket, we can factor out b to the power of n. So our final answer is a to the power of m times p minus s plus b to the power of n times r plus h. This shows how we can simplify expressions with powers by recognizing and grouping like terms, then factoring out common bases. To summarize, when adding or subtracting terms with the same base, we group the like terms together, factor out the common bases with their exponents, and then simplify the coefficients. Remember that this approach works only when the bases and their exponents are identical within the terms we're combining. Thank you for watching this lesson on adding and subtracting numbers with exponents. Practice these concepts with different expressions to build your confidence with algebraic manipulation. Welcome to this math tutorial. Today, we'll be solving some math problems involving exponents and order of operations. Let's start with our first example. We need to find the value of 2 plus 3 times 4 squared. When solving this problem, we need to follow the proper order of operations. Remember the acronym PEMDAS. Parentheses, exponents, multiplication and division from left to right, and addition and subtraction from left to right. First, we need to evaluate the exponent. 4 squared equals 4 times 4, which equals 16. Next, we perform the multiplication. 3 times 16 equals 48. Finally, we do the addition. 2 plus 48 equals 50. Let's move on to our second example, where we need to calculate 2 to the power of negative 3 plus 3 to the power of negative 2. Remember the rule for negative exponents. A to the power of negative n equals 1 over a to the power of n. First, let's convert each term with negative exponents to fractions. 2 to the power of negative 3 equals 1 over 2 to the power of 3. And 3 to the power of negative 2 equals 1 over 3 to the power of 2. Next, let's calculate the values in the denominators. 2 to the power of 3 equals 8, and 3 to the power of 2 equals 9. To add these fractions, we need to find a common denominator. The least common multiple of 8 and 9 is 72. So we'll convert both fractions to equivalent fractions with denominator 72. Adding the numerators, we get 9 plus 8 equals 17. So our answer is 17 over 72. Let's solve our third example. The quantity 4 squared to the power of negative 1 plus the quantity 2 to the power negative 3 squared. To solve this, we'll use the power of a power rule. When we raise a power to another power, we multiply the exponents. First, let's apply the power of a power rule. For the first term, 4 squared to the power of negative 1 becomes 4 to the power of 2 times negative 1, which is 4 to the power of negative 2. For the second term, 2 to the power of negative 3 squared becomes 2 to the power of negative 3 times 2, which is 2 to the power of negative 6. Now let's convert these negative exponents to fractions. 4 to the power of negative 2 equals 1 over 4 squared. 2 to the power of negative 6 equals 1 over 2 to the power of 6. Next, let's calculate the values in the denominators. 4 squared equals 16, and 2 to the power of 6 equals 64. To add these fractions, we need a common denominator. The least common multiple of 16 and 64 is 64. So we'll convert the first fraction to an equivalent fraction with denominator 64. Adding the numerators, we get 4 plus 1 equals 5. So our answer is 5 over 64. Let's solve our final example. 2 plus 3 times 4 to the power of negative 1 minus 2 times 5 to the power of negative 1. Let's start by converting the negative exponents to fractions. 4 to the power of negative 1 equals 1 over 4, and 5 to the power of negative 1 equals 1 over 5. Next, let's perform the multiplications. 3 times 1 over 4 equals 3 over 4. 2 times 1 over 5 equals 2 over 5. To add and subtract these fractions, we need a common denominator. First, let's convert the whole number 2 to a fraction. 2 equals 40 over 20. The least common multiple of 4, 5, and 20 is 20. So we'll convert all fractions to equivalent fractions with denominator 20. Adding and subtracting the numerators, we get 40 plus 15 minus 8, which equals 47. So our answer is 47 over 20. That completes our lesson on exponents and order of operations. Remember to follow PEMDAS and to convert negative exponents to fractions using the rule a to the power of negative n equals 1 over a to the power of n. Thanks for watching. Welcome to this math tutorial, where we'll be solving expression problems involving powers. Let's start with our first example. We need to simplify the expression 3 to the power of 5 times the quantity 4 to the power of 6 plus 4 to the power of 6 plus 4 to the power of 6, all divided by 6 to the power of 6. First, let's simplify what's inside the parentheses. We have 3 terms of 4 to the power of 6 being added together, which is the same as 3 times 4 to the power of 6. Next, we can combine the coefficient 3 with 3 to the power of 5. Since 3 to the power of 5 times 3 equals 3 to the power of 6, we can rewrite this as 3 to the power of 6 times 4 to the power of 6, all divided by 6 to the power of 6. Now we can rewrite this expression in a different form. Note that 3 times 4 equals 12, so we can write the numerator as 12 to the power of 6 divided by 6 to the power of 6. So we have 12 to the power of 6 divided by 6 to the power of 6. This is equivalent to the fraction 12 over 6, all raised to the power of 6. Finally, 12 divided by 6 equals 2, so our answer is 2 to the power of 6, which gives us 64. Now, let's look at our second example. We need to simplify the expression 2 minus 4 times 1/2 to the power of 3. First, let's calculate 1/2 to the power of 3. This can be rewritten as 1 divided by 2 to the power of 3. 2 to the power of 3 equals 8, so we have 1 divided by 8. Next, we multiply 4 by 1/8, which gives us 4/8, or 1/2. Finally, we subtract 1/2 from 2, which gives us 3/2, or 1.5, as our final answer. In this tutorial, we've learned how to simplify expressions involving powers by using various properties such as the product of powers with the same base, power of a product, quotient of powers, and power of a fraction. Remember to apply these rules carefully and simplify step by step to get the correct answer. Let's examine an important algebraic concept about squares of sums versus sum of squares. We have 2 expressions to compare. 4 squared plus 3 squared, and the square of the sum 4 plus 3. Let's analyze the first expression, 4 squared plus 3 squared. In this expression, we first square each number individually, and then add them together. 4 squared equals 16, and 3 squared equals 9. Adding these results, we get 16 plus 9 equals 25. Now for the second expression, the square of 4 plus 3. In this expression, we first perform the addition inside the parentheses, which gives us 4 plus 3 equals 7. Then we square this result. 7 squared equals 49. As we can observe, these two expressions give different results. 4 squared plus 3 squared equals 25, while the square of 4 plus 3 equals 49. Therefore, we can conclude that the sum of squares is not equal to the square of the sum. We can generalize this result. For any values a and b, the sum of squares a squared plus b squared is not equal to the square of the sum a plus b squared. Let's now examine a similar comparison with subtraction. We have two new expressions, 4 squared minus 3 squared, and the square of 4 minus 3. For the first expression, we again square each number first, then subtract. 4 squared is 16, and 3 squared is 9. Subtracting, we get 16 minus 9 equals 7. For the second expression, we first calculate what's inside parentheses, for minus 3 equals 1. Then we square this result. 1 squared equals 1. Again, we observe that the two expressions yield different results. For squared minus 3 squared equals 7, while the square of 4 minus 3 equals 1. So we conclude that the difference of squares is not equal to the square of the difference. In general, for any values a and b, a squared minus b squared is not equal to a minus b squared. These comparisons highlight an important algebraic principle. Operations with exponents do not distribute over addition or subtraction in the way students sometimes mistakenly assume. Remember, the sum of squares is not equal to the square of the sum, and the difference of squares is not equal to the square of the difference. Welcome to our math lesson on the addition and subtraction of powers. Today, we'll learn how to simplify expressions where we have the same base raised to different powers, and we need to add or subtract them. Let's start with our first example. We need to calculate 2 to the power of 100 plus 2 to the power of 100. When we have the same base raised to the same power, we can factor out the common term. Let's start by rewriting this as 2 to the power of 100 times 1 plus 1. Next, we can simplify 1 plus 1 to get 2. So we have 2 times 2 to the power of 100. Now, we can use the rule of multiplying powers with the same base. When we multiply the same base raised to different powers, we add the exponents. So, 2 times 2 to the power of 100 is equal to 2 to the power of 1 plus 100, which gives us 2 to the power of 101. Let's move on to our second example. Here we need to calculate 27 to the power of 11 plus 27 to the power of 11 plus 27 to the power of 11. Similar to our first example, we can factor out the common term. Let's rewrite this as 27 to the power of 11 times the sum of 1 plus 1 plus 1. We can simplify 1 plus 1 plus 1 to get 3. So we have 3 times 27 to the power of 11. Now, let's recall that 27 is actually 3 cubed. So we can rewrite 27 to the power of 11 as 3 cubed to the power of 11. We can then use the power of a power rule. When we have a base raised to a power, and that entire expression is raised to another power, we multiply the exponents. 3 cubed times 11 equals 33. So we have 3 to the power of 1 times 3 to the power of 33. Finally, using the rule of multiplying powers with the same base again, we add the exponents. 3 to the power of 1 times 3 to the power of 33 equals 3 to the power of 1 plus 33, which gives us 3 to the power of 34. So what's the general rule for adding or subtracting powers with the same base? Unfortunately, there isn't a simple formula like there is for multiplication or division of powers. When we add or subtract powers with the same base, we need to factor out the common base raised to the minimum exponent, and then perform the required operations. Let's visualize our second example with a diagram to better understand what's happening. We start with 3 identical expressions, 27 to the power of 11. This is like having 3 identical large numbers. We're adding these three large numbers together. When we factor out 27 to the power of 11, we're recognizing that we have the same large number 3 times. So instead of adding them one by one, we can multiply this large number by 3, which is much easier. In conclusion, when adding or subtracting terms with the same base raised to the same power, we can factor out the common term and simplify. This technique makes calculations much more manageable, especially with large exponents. Remember the key properties we use today: factoring out common terms and the rules for exponents, particularly the rule for multiplying powers with the same base and the power of a power rule. Welcome to our lesson on simplifying expressions with powers. Today we'll look at how to add and subtract powers with the same base. Let's start with our first example. We have 15 times 5 to the power of 20 plus 10 times 5 to the power of 20. First, let's rewrite the expression to see the coefficients more clearly. 15 can be written as 3 times 5, and 10 can be written as 2 times 5. So we have 3 times 5 to the power of 20 plus 2 times 5 to the power of 20. Now we can use the product rule for exponents. When we multiply terms with the same base, we add the exponents. In this case, we have 5 to the power of 1 times 5 to the power of 20, which equals 5 to the power of 21. Now we can factor out the common term 5 to the power of 21 from both terms. We get 5 to the power of 21 times the quantity 3 plus 2. We calculate 3 plus 2, which equals 5. So we have 5 to the power of 21 times 5 to the power of 1. Using the product rule again, we add the exponents. 21 plus 1 equals 22. So our final answer is 5 to the power of 22. Now, let's move on to our second example. We have 7 to the power of 20 plus 42 times 7 to the power of 19. First, we notice that 42 can be written as 6 times 7. So our expression becomes 7 to the power of 20 plus 6 times 7 to the power of 19. Using the product rule for exponents, 6 times 7 to the power of 19 becomes 6 times 7 to the power of 20. So our expression is now 7 to the power of 20 plus 6 times 7 to the power of 20. We can factor out 7 to the power of 20 from both terms. This gives us 7 to the power of 20 times the quantity 1 plus 6. We calculate 1 plus 6, which equals 7. So we have 7 to the power of 20 times 7. Using the product rule again, we have 7 to the power of 1 times 7 to the power of 20. Adding the exponents, we get 7 to the power of 21, which is our final answer. Let's summarize what we've learned about simplifying expressions with powers. First, we identify terms with the same base and look for ways to rewrite coefficients. Second, we use the product rule for exponents, which says that when multiplying powers with the same base, we add the exponents. Third, we factor out common terms to simplify our expressions. And finally, we apply the rules again as needed to reach our final answer. These techniques are powerful tools for simplifying complex expressions with exponents. Thank you for watching this lesson on simplifying expressions with powers. Practice these techniques with different examples to build your confidence. Welcome to our math video lesson. Today we'll solve some algebraic expressions with exponents. These problems involve manipulating expressions to find their simplified form. Let's start with our first example. We need to find the result of the following expression: 10 times 2 to the power of 17 plus 12 times 2 to the power of 16 plus 3 times 2 to the power of 21. Let's rewrite this expression to make it easier to work with. We can express 10 as 5 times 2, 12 as 3 times 4, and expand 2 to the power of 21 using exponent properties. Now, we'll use the property of exponents that says when multiplying terms with the same base, we add the exponents. So 5 times 2 to the power of 17 becomes 5 times 2 to the power of 18. Similarly, for the other terms, we get 3 times 2 squared times 2 to the power of 16, and 3 times 8 times 2 to the power of 18. Let's simplify further. We can rewrite the middle term. 3 times 2 squared times 2 to the power of 16 becomes 3 times 2 to the power of 18. And 3 times 8 times 2 to the power of 18 stays the same, which is 24 times 2 to the power of 18. Now, since all terms have the same power of 2, we can factor out 2 to the power of 18. We get 5 plus 3 plus 24, all multiplied by 2 to the power of 18. Step 5. Let's add the numbers inside the parentheses. 5 plus 3 plus 24 equals 32. So we have 32 times 2 to the power of 18. Step 6. We can express 32 as 2 to the power of 5. So we have 2 to the power of 5 times 2 to the power of 18. Using the exponent rule for multiplication again, we add the exponents. 5 plus 18 equals 23. Therefore, our final answer is 2 to the power of 23. Let's move to our second example. We need to solve 5 times a to the power of 3, all squared, minus 4 times a to the power of 2, all cubed. Step 1. First, let's use the power of a power rule to simplify the expressions with nested exponents. When we have a to the power of 3, all squared, we multiply the exponents. 3 times 2 equals 6. Similarly, a to the power of 2, all cubed, becomes a to the power of 6. So we get 5a to the power of 6 minus 4, a to the power of 6. Since both terms have a to the power of 6, we can factor it out. We get open parenthesis 5 minus 4 close parenthesis times a to the power of 6. Step 3. Now we calculate 5 minus 4, which is 1. So we have 1 times a to the power of 6. Step 4. Finally, 1 times a to the power of 6 is simply a to the power of 6, which is our final answer. In conclusion, we've solved 2 algebraic expressions by applying various properties of exponents and algebraic manipulation. Remember these key rules. 1. When multiplying terms with the same base, add the exponents 2. When raising a power to another power, multiply the exponents 3. Factor out common terms to simplify expressions. Practice these techniques, and you'll become proficient at solving similar problems. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.